Welcome back. Lecture 31 today, Math 141. We are in the middle of related rates, literally, so we will probably spend the whole day today on that, and hopefully if you had any questions, they'll be cleared up. Keep in mind that when you're looking at problems and the diagram is given to you, try to envision the situation where you yourself had to come up with a diagram instead, because probably on more than half the problems you're going to have to come up with your own diagram. So thankfully they give us some pictures, some nice pictures sometimes, but keep in mind that you've got to come up with your own picture a lot. And a diagram, I think, is important to label the things that are changing, label the things that are fixed, and go from there. So a diagram is important. And then as we go through problems, even if the diagram is given, think of yourself having to kind of decide what do I know, what rate do I know, what do I call it? Is it dA over dt, dV over dt? It's d something over dt. It's just a matter of deciding what it is. And usually there's at least one other rate involved in the problem. We finished a problem yesterday, and I said I wanted to do a problem similar to it, but did not involve the angle. So here is that problem. I'm going to slightly change the directions. We had a kite 100 feet above the ground, and it was staying at that height, which I want to keep that the same. So it's going to stay 100 feet above the ground. It moves horizontally at a speed of 8 feet per second. I think I'm actually going to change that. And I want to do similar things in this problem, but I don't want to deal with the angle between the string and the horizontal. So yesterday we figured that as the kite went out there to the right and stayed at this height, this angle kept getting smaller, and we've actually found out the rate at which it was decreasing. I'd like to leave the angle out of this problem the second time and see what it looks like. So I want to keep the kite at a height 100 feet above the ground. This time we're going to establish that we want to pay the string out at a certain rate. So that's going to be getting longer. The hypotenuse is going to be getting longer. And as the hypotenuse gets longer, then we can figure out this dH over dt at a certain point in time. So similar situation. We will have the kite right there. There's the string. The string is going to be paid out at a certain rate, and we're going to know that in this problem. The height of the kite is going to remain fixed at 100 feet. And we called this h yesterday. Let's continue with that. So the kite is 100 feet above the ground. That's fixed. That stays the same. The string is going to be paid out at a rate of, I don't know, let's make up a rate, letting string out so where it's not like just skimming out of your hands and drawing blood on your fingers. What?
First.
4 feet per second?
Yeah, sure.
Okay. So we're letting string out. So the kite's going to stay the same height, just as it did in the example yesterday. So we have more string out, and the kite stays the same. S is getting longer, and H is also getting longer. So we want to find the rate of change of H. Now, what we do have to interject in this problem is at a certain point in time. So let's say when 200 feet of string are actually out. So that S is 200. Not always 200 because it's changing, but the instant in time that we're locking in, we want S to be 200. So notice the angle between the string and the horizontal are not involved at all in this problem. So in the problem yesterday, we had a trig function. What did we have? We wanted 100 and h in the problem, so we used either tangent or cotangent, right? So we had a trigonometric statement. We're not going to have a trigonometric statement here because we don't know about the angle, nor do we care about the angle in this problem. So we want an equation that has S and h and 100 in it. What is that? Okay, Pythagorean. S squared equals h squared plus 100 squared. So that, regardless of how much string has been paid out or the rate at which string is being paid out, that is an equation that interrelates the